Continue here with the German efficiency in the SAGE program. Wonderful to see you. We have a next speaker who's going to talk about the best practices of digital insect monitoring and forecasting. He is with us already. He's the co-founder and the CTO at 𝐸𝐴 and Trapview. And please give him also a round of applause to Matej Stefancic. Thank you so much.
Thank you, everyone. Yeah, let's start, First thing is, maybe we forget about that, but most of our decisions is data-based. Even for today, what we should wear. It's based on what's the event, what we have in the closet, what kind of weather we have. Very often we forget that even basic things are data-based. And in agriculture, it's no different. So when we talk about data, there are a couple of basic principles that always apply. And it's very easy, right? You need to collect, you need to purify, and then you can enhance the data. I will give you an example from perspective of pest insect monitoring and forecasting, how this works. So first step, data collection. For this, you have automated traps, which are taking pictures, sending those pictures, well, first catching insects, then taking pictures, sending those pictures to the cloud for further processing. It is a very crucial step, because if you have garbage in, then it's game over, right? You cannot improve something that has a flaw at the very beginning, at the intake. And that's why this step is also extremely R&D intensive, because you have to understand the insect, you have to see what kind of trap is needed, what works best, how you catch best. Then those traps need to be also as self-sufficient or autonomous as possible. Rule of thumb is it shouldn't be touched basically for the whole season, except for changing the pheromone maybe every month, month and a half. That's why it's not just basic things like solar panel powering the battery. It's not just basic thing like sending the pictures or the data from everywhere. It's also about self-cleaning and understanding this, so that you don't have to go there and change the sticky liner. That's why I said this step is very R&D intensive. Next step is data purification, how we separate wheat from chaff. And this one is, well, both very data intensive, but also very labor intensive from a perspective of the person or the company that is providing such data. Let's play a simple game on that. So I'll show you a picture, and you establish or you guess how many insects are there, right? Here is the warm-up. It's on bedrock, so this is the olive fruit fly. Guess how many? 20? 20, okay. 24, good enough. That was a warm-up. Yeah? Let's move to vegetables. Let's move to tuta absoluta, the tomato leaf miner in tomato. Now. More than 20, just a hint. 800, yeah. Too much, probably, but 500, okay. It wasn't marked, maybe that was the problem, huh? So, the number is 484. What I wanted to say, very often in data purification, we forget about the importance of this step. We forget about how crucial it is to really extract the information from the raw data. And yes, over the years, we built the biggest database of pictures of insects in the world. Yes, we can apply deep learning very efficiently, but there is a problem with how to be consistent. So if we look at the result of let's say, of the deep learning algorithm. On the y-axis, you have how accurate it is. On the x-axis is days. Yeah? And you can see that it can be very accurate, but there are some situations during the season where this accuracy falls almost to zero. Whether it's a really high pest pressure, whether it is, I don't know, wind and debris comes in. Sometimes different insects are taking refuge in the trap. What do you think is the useful value of such non-validated data? It's close to zero, because you still need to look at all those pictures, you know, I showed you before, the tuta absoluta example, and try to figure out, was the algorithm right or wrong? You don't know where it's wrong. That's why we introduced the data validation, so we do that for you. And in this way, the accuracy never falls below 90 degrees. 90%, sorry. And that's the separation between the data you can trust and the data that is just data, that cannot be trusted, that cannot be used for creating insights. Okay, so we collected the data, we purified it, we know we have good data set. Now it's time to bake pizza, right, out of it. So what you can do with that, when you have daily catches, validated ones, when you have weather data, when you understand population dynamics, when you understand biology, so what is the correlation between temperature range and duration of certain development stage, then you can do things like here, you know. You can predict when you will have eggs, when you will have different stages of larvae, and you can also take into consideration not just timing, but also intensity, and also what it means if you apply crop protection, right? Because basically, it's not just monitoring pest insects, it's about understanding when is the right timing to do something about that. And once you have all this, when you master, as I mentioned, the technology, the process, the service with validation and also local support and so on, then you can have a really accurate prediction of when, where, and will the pest insects be your problem. At which development stage it will be, because it's not the same if you're using oviside or larvicide or broad-spectrum insecticides, which are more or less not allowed in Europe anymore. And you can do this for the next 7 to 10 days with the accuracy of a single day. So you know when is the right time. You avoid misspraying. Okay, lots of talk about data, but I wanted that we are on the same page in understanding what it means, you know, because it's not just let's collect. It's about what you do with it when it becomes useful. Now let's see a couple of best practices or use cases when such data is useful. The first very obvious one is when you need to manage logistics, right? When you have either large area to cover, when you have remote locations that you need to check. Think about, okay, I know it's not the right occasion, but think about forestry. You know, when you have a problem in remote area, somewhere in the mountains and something like that. But even when you have a large operation, or if you are a food processor and you want to see, you know, what is happening with the fields from which you're collecting your produce, you want to understand what is happening in one area, and logistics plays a major role in that, how you manage this data collection. Even if you're a smaller grower but have more, let's say, fragmented fields, again, it's not all in one places, and not all places are the same. There is a difference between intensity, there is a difference what your neighbors are doing, there is a difference in whether there is some natural refuge for the insects nearby, and this is what you get with the automated monitoring. The second the second benefit is when you need to manage rotating crops, vegetables being the prime example of that. Here is a case from US, Salinas Valley. It's one valley, focused very much, okay, on different vegetables, but brassica, for example, is a big crop there. And it's rotating. Every 3 months, a new crop comes in. And otherwise, from a weather perspective, it's pretty much the same. It's flat, yes, maybe in this part closer to the ocean, it's a little bit different, but otherwise, if we would be using only degree day modeling, everything would be the same. The pest would be in the same development stage, the intensity should be pretty much the same, and so on. And in those cases, it's really crucial to have this automated, because it's not possible to do manually that kind of precise prediction for the next week. Last but not least, adapting to the climate change. But it's more of a case I want to show. This is in grapes, but doesn't matter. They had one pest that they stopped monitoring end of August, because they said after that it's not a problem anymore. Some 12 years ago, they observed for the first time that there is the third generation of this insect appearing a couple of weeks prior to the harvesting. And last year, we've seen in the same area that it's already the fourth generation. So yes, we all know it's getting warmer, but the insects are also adapting to this. Another good example of that is Tuta absoluta, the big numbers we had before. It came to Europe 15, maybe 20 years ago, something like that. At the beginning, was not a problem because it didn't adapt to our climate. So the biggest pest pressure was in November, where tomato was harvested. It took 3 to 4 years, and now it's a major pest in the Mediterranean basin. So I guess that concludes the presentation. I hope I was able to give you a little bit of perspective of the importance of the data, what you can do with that. Of course, you're all welcome. We are just behind the corner here. Stop by. We can explain you much more about that, but yeah, just stop by.
Thank you, Matej from Trapview. Are we open for questions? Do we have any questions coming from the audience? Yes, I come to you. We just give you the microphone so that everybody can hear your question.
Thank you. Interesting talk. I am just curious. The key for the accuracy of the prediction is the quality of the pheromone. How do you ensure that across all the traps, the quality of the pheromone is more or less from the specificity and quality more or less the same, so that your prediction can be precise?
Thank you.
Yeah, you're right. Standardization is a big portion of it, right? So we standardize the trap. This is one part. The other is standardizing the attractant. Yes, pheromone is used in most cases, but not the only. It's not the only attractant, right? Very often, especially when you have mating disruption, you would use a combination also with the feeding attractant, because otherwise you can't detect the size of the population. You can detect only the effectiveness of whether mating disruption system works or not, but not what is your real pest pressure. Yeah, we try to standardize this. That usually means when we set up a network of traps, it's usually with the pheromone from the same producer. And we also work with quite a few different pheromone producers, how to make it as season long lasting as possible. So when you attract with color, for example, like yellow sticky card, you standardize these. Sometimes you attract by light, sometimes you attract with the feeding attractant. But when it comes to pheromone, we are always looking for solutions how to standardize in first place, and second, how to make it as long-lasting as possible. As I said, trap should not be touched for the whole season except changing the lure.
Thank you. I don't see any more questions, but I do have a question.
Sure.
What do we need to know about 2024 and the past development in 2024? What do we need to be prepared for? An early warning now, here, coming live from the Farming Forward stage.
Yeah, so I think the biggest thing that changed already is the lack of broad-spectrum insecticides that we had. So if you have broad-spectrum insecticide, then basically the only data you need is the calendar. Yeah, you spray every 2 weeks or whatever, and that's it. However, whenever you go to more specific products, whether it's either more to the organic side or more targeted chemistry, timing is crucial. And that means timing has reduced to 2, 3, maybe 5 days. After that, it's just useless. So in terms of trend itself, yes, it is very much about the timing, about avoiding missprays. And another thing, which is also a big problem, is the lack of workforce. That's why the optimization of the logistics and collecting the data and so on. Those two.
Thank you so much. Where do we find you if we want to come back to you?
We are just here at the corner, right?
So there is no excuse to not find you. Thank you so much.
No.
Matej, thank you. This is your round of applause.
Thank you.
Merci beaucoup. Thank you.